Hello there. My name is Michael Larsen, and I helped write this book right here called Software Testing Strategies. I would like to share with you what we like to refer to as the puzzle pieces of good testing. Oftentimes, test cases are given more weight than they deserve. Also, a lot of the time, test cases are confused for a lot of other things. What we like to refer to instead of a test case is all of what goes into building so that you can actually get to the point to where you can do the testing you need to. We refer to this as a test recipe. Additionally to that, we also want to consider the coverage that you do, the defects that you would find yourself dealing with, what is your testing schedule, what is your testing strategy, and finally, how would you communicate what you've learned, what we'd oftentimes refer to as a testing dashboard. We think there's been a lot, maybe too much attention placed on test cases. Are test cases important? Sure they are. But test cases come and go. There's relative details to them that might not be terribly useful once you've run them 1, 2, 3 times. But there's a lot of other things that you're going to have to deal with that are always going to be there. First of all, we want to talk about recipes. Now, what's the difference between a test case and a test recipe? Test recipe involves everything that brings you to a particular point. A lot of things that you deal with when you're talking about software testing primarily deal with what do I need to do to get me to a point that I'm actually able to test. In a simple case, that might just be getting to a login screen. Okay, now I can test the login screen. In some other applications, you may have to build a Docker container. You may have to populate a database. You may have to install a program. You may have to spin up a number of applications. You may need to navigate to certain elements within your application. You may need to make sure that certain microservices are set up. You see, all of that could be considered what you need to be able to execute one test case. But all of that is critical. So we want to focus on, rather than your individual test cases, which sure, you're going to be able to deal with them, but you're always going to have to deal with the recipes. And since you're always going to have to deal with the recipes, let's make sure that we give that the attention it deserves. When Matt and I were discussing how to put together, for example, these puzzle pieces, and we were talking about how do we know that we've got all the steps that we care about in place. It's interesting because we both use the same vernacular and we didn't even realize it. He had asked me and said, hey, how are you putting together certain test case scenarios, or how are you putting together your examples? I said, well, I have these things I know that I need to do, and I called them snippets. And he laughed. He says, really? That's what I call what I do too. So we both realized we used a similar vernacular for this. Now, what is a snippet? A snippet is, let's say that you know that you have to do a certain install task, right? And that install task requires 5 or 6 steps. First couple of times, you might run those steps manually. Well, what you realize is, since you know you're going to do that all the time, you put that in a bash script. And you set up the bash script so that you give it some parameters so it's easy to run. There. So you know that every time you want to start, you start with that bash script. That's a snippet. You start with that snippet. And then you move on to something else that you might need to do. Oh, we need to set up the database. Oh, okay, well, the database needs to be populated with these tables. Hey, we could just run some select statements. Oh, guess what? You could actually do that again with a bash script or some other tool that will allow you to load that up and put it in place. There's another snippet. What do you notice? As you keep walking through these items, you start to notice that these snippets interconnect with each other. And by the time you take 5 or 6 snippets and you interconnect them, you realize you've got a workflow that gets you to where you want to go to now be able to do whatever testing you need to do. I'm sure that many people know the agony. And remember, make sure you capture everything about your test case. And you have to populate something. And you're constantly writing in, log into the system, go to this page, click on this link, and you know you're doing it all the time. Our answer is, well, you know that's a snippet, define it as such. Give it a simple name, put it over here. Define another block, you know you're going to do it. There's a snippet, put it over here. So what you have is now you have these recipes that allow you to get to each point you want to go to And then your actual tests, those are the ones that are going to vary. Now, if you want to say, have a few things written down so that you know what to look at, or you want to go on an exploratory charter and look through given areas, you can do that. And you're ready for them. But you've captured the really important information up front. A lot of the time, your cookbook may be very random, depending upon what you're working on. What you want to do is you want to minimize the random. Just like in cooking, you want to minimize the random. If you have a set of recipes that you use, that's great. You know what ingredients you need. You know how to do it start to finish. But if you understand things like flavor profiles, and if you understand how certain ingredients work together, now a lot of recipes can be broken down into understanding how certain ingredients work together. And if you have that understanding, you can create a lot of recipes on the fly without necessarily having to understand how to piece each one of them together. In software, we look at this as coverage. And again, what does coverage mean? It means, did we test the right things well enough? So as we go through and we figure out what our coverage needs are, as we figure out what pieces go together for making sure that we've covered the things we need to, that we've looked at the right product, that we've looked at the right configurations, as you start to understand those, again, that's like a flavor profile. You start to understand that to get the right amount of coverage you need to make sure that you are getting everywhere you need to, you have certain calls and actions and recipes that you would plug together in a certain order or in a certain way to make sure that you're getting the coverage that you need. One of the things we often use to communicate our level of coverage or our feeling of how well something has been tested is we can give it a number system. We can go from 0 to the fact that it has not been tested at all, to 10, it has been tested 100% completely and fully. By the way, there really is no such thing as a 10 unless you're talking about very simple programs. It's hard to get every single possible permutation for any kind of a sophisticated program that you have exhaustively and completely covered every possible permutation. In most cases, it cannot be done. And so we don't even try. But when you say that we have used every amount of our resources to look at every possible permutation that we are able to get to with the time that we have, under the workflow situations that make the most sense, under this configuration with these data values that are most relevant, we have done all of that, and we feel confident that this has addressed the vast majority of areas that our customers and that our team is going to care about. At that point, you might as well, the stakeholder is probably going to say, fine, that's a 10 for me. Good enough. And just roll with it. One of the things that goes with this, I'm going to short circuit because we said that dashboards are important ways of communicating. Dashboards are a great way of communicating coverage too. So if you have a number of features or you have a number of areas or a matrix that you want to look at, putting that up on a board, now whether that board is a whiteboard with sticky notes on it or you write in the details, or you take a monitor that you place up on a wall and you just run it and you update the information with what's going on in that system, that will tell people how far you've gone and what you've covered. We refer to this kind of a public-facing dashboard or something you can look at on the screen as an information radiator. And information radiators are very helpful in two aspects. The first aspect is it's helpful because you can get a very quick visual of what's happening. You can see, if you notice that the board is mostly green and it's filling and it's mostly green, that's a good sign. If you notice the board has a smattering of green and red, but it's only in a simple corner, okay, we're finding problems and we haven't done very much. If the board is 80% full and a lot of red is in there, hang on, let's stop, what's going on? And of course, if you see the board and it's 90% green and just a couple of reds, you can pick off the reds and say, okay, We understand those problems, and you can quickly make decisions based off of it. You always have a feel of what's going on. Let's have a quick chat about defects and what defects actually represent. A famous and oft-repeated description is a bug is something that bothers somebody. It bugs somebody. But I believe this is Jerry Weinberg's definition, is a bug is an issue or a problem being faced by someone who matters. And the someone who matters needs to be emphasized. There's oftentimes lots of problems in software that most people will never deal with, never come across, in a feature that they're never going to work with. The bug is there, but as far as they're concerned, it doesn't matter to them. It's got nothing to do with their workflow. They're not doing anything with it. But if there is a critical issue, or there is a stop, or it makes it very difficult, or usability is not there for being able to effectively list something for sale, or close out an item, or pay for it, that's a bug that's going to be definitely critical, because it affects money, it affects payment, it affects collection. And there's many others too. If something gets under the skin of somebody important enough, and mind you, important doesn't necessarily mean you have to be part of the C class or some high up mucky muck. It could literally be, our customers can't pay for our product. What do we do? That's mission critical. There's a defect that matters. And the point is, there's defects that can be everywhere from absolutely catastrophic to very low and not terribly important. But a number of low, not terribly important issues, if left unaddressed, can absolutely indicate that the software quality is not good, or the usability is poor, or it's leaving a bad taste in the customers who are using its mouth, that they'd prefer not to use it. And in this day and age, especially when it comes to apps, many people do not wait around to say, hey, I'm using your app and it doesn't really do what I want it to do, or it's not very usable. If you're not somebody willing to address those quickly, they're just not going to use it. They're going to stop using your app, they're going to uninstall it and go someplace else. So that's a challenge that you have to face. And realizing that what might be a very low level bug could over time turn out to be very important, because those low level bugs, when stacked up, can make a big enough issue to make somebody leave. Scheduling is important when it comes to doing your testing too. And scheduling really comes down to risk management and risk mitigation. What are the most important things that you need to address? How do you know that those are the important things? And more to the point, how do you know that you have what's necessary to mitigate those risks? And it's a constant battle. You're always thinking, what are the risks that I have to consider in regards to operating our software? Having that discussion and understanding what those risks are is critical. And then once you've done that, you can then say, okay, what are the things I can do to limit that level of risk? When it comes to software testing, we have so many ideas, but we don't have enough time. We can't run every conceivable option. So what do? Well, you're going to have to decide what's the most important. What can you prioritize? And how can you make sure that those items get looked at? What's the best way to prioritize? Figure out what your biggest risks are. Understand that if you don't address those, you may be facing dragons. And if you can figure out how many of those you can possibly handle within the time that you have, and put the biggest risk items up front, will you cover everything? Absolutely not. Will you cover the most important things? Much better chance. So you find yourself in a situation where you have a very limited amount of time to test, and you want to be as effective as you possibly can. You want to identify those areas that really matter, and you want to hit the ground running and be as effective as possible. So you need a strategy. We're going to give you a quick strategy that you can use. And frankly, we are not the ones who invented it. This is credited to Karen Johnson, who is a colleague of ours, who we have directly worked with, met at, and conferred with at conferences over the years. And this is her invention, or at least it's where we first heard about it. So she has a mnemonic for regression testing. It's called RCRCRC. Recent. So what new features and new areas of code are more vulnerable? What should we be looking at? Core. What essential functions must continue to work? Risk. Some areas of an application are riskier than other areas of the application if you don't address them. Configuration sensitive. That's the second C. In other words, code that depends on an environment or a third-party tool or application that you may have limited control over. Repaired. In other words, if you make a bug fix and you fix one part of a problem, you might be introducing a new issue someplace else down the road. And then the last C is for chronic. And chronic means that there's going to be areas of your application that are going to perpetually be flaky, and you're going to have to handle with care. So with all that, we can take this information and we can put it together and we can assemble each of these pieces. And now we will have a pretty direct and effective test strategy. So number one, we want to have our recipes. We want to figure out what are all the pieces that we need to be able to configure and put together our environment to do the type of testing that we want to do. Next, we need to figure out what kind of coverage can we do? What do we have the time to do? Are we only going to be able to work on a particular module, or are we going to look at the whole application? Do we have a day? Do we have a week? Do we have a month? What are we working with? We have our census of risk. What are the things that we really need to make sure are in good shape? And what things can we mitigate or step away from if we don't have the ability of really giving all the time and attention it deserves? You then have your coverage heat. You look and see, where are the areas we're hitting? What has changed? And if we've changed something, do we want to look around those areas just to make sure that we haven't introduced something weird? And then, of course, with all of that, you can look at the progress of the builds that you do, how many iterations you've had to do, what defects have been introduced, and what defects have been fixed, rebuilds. In other words, how have you mitigated all of these risks, and do you feel that you have? And then finally, with all of that information, you can communicate it using an effective dashboard. And whether that dashboard is a whiteboard that you write on, or it's a computer monitor displayed up on the wall as an always on 24/7 information radiator, you can communicate what you're doing. There you go. Those are puzzle pieces. A fair number of them, and I've tried to make this as short and compact as I can, and I could go on for much longer, but let's start with that. And if you have any questions, please feel free to leave them in the comments, and we'll be happy to address them.